Great. So the first thing you need to be able to do is graph functions with transformations. So we need to know the parent function absolute value. So that is a V-shaped graph through the origin. And then, write the equation first. Okay, well, we're shifting it right 5 and up 2. So 1, 2, 3, 4, 5, and up 2. So we've just got slope of 1, slope of -1. So let's see, absolute value to shift to the right, you are going to do x minus 5 inside the absolute value, and to go up you need a plus 2 outside the absolute value. Oh, there's my equation. Absolute value of x minus 5 plus 2. The domain is all real numbers because it goes forever side to side, and the range looks like it starts at positive 2 and goes up forever. So y is greater than or equal to 2. A square root function, it's been vertically stretched by a factor of 2 and flipped over the y-axis. So this is the y-axis flipping this way. So my equation is 2 to stretch it, and then a square root of -x to flip it over the y-axis. So normally the square root function starts at 0, over 1 up 1, over 1, 2, 3, 4 up 2, and over 9 up 3. So there's the parent function. I need to flip it over and stretch it. So 0, 0, over 1 and up 2, 1, 2, 3, 4 needs to be twice as tall. So instead of up 2, I'm going to go up 4. And then over 9 needs to be twice as tall, so I need to go up 6. So there it is. My domain, all my x values are now less than or equal to 0, but my y values are still greater than or equal to 0. So they're all above the x-axis still. Exponential increasing, it'd be nice to know what that looks like, but I shouldn't have asked because I'm not going to have you graph that one by hand. So I'm going to cross out number 3. Number 4, cubic function. So cubic looks like this originally, right? It has been shifted down 2 and vertically shrunk, so it's less tall by a factor of 1/2. So y equals a cubic function shifted down 2, so x cubed minus 2. So shifted down 2 and vertically shrunk by a factor of 1/2. So normally it's 0, 0, 1, 1, 2, 8, -1, -1, and -2, -8. So this would have been the parent function. So I'm going to shift all those points down 2, but instead of going over 1 up 1, I'm only going to go up 1/2. And instead of going over 2 up 8, I'm only going to go up 4. 1, 2, 3, 4. 1, 2, 3, 4. So they're shifted down 2 and shrunk. So domain and range are still all real numbers. So this is stretching side to side forever and up and down forever. All right, so we've got quadratic graphs. So let's see, this is in standard form. So this is when I do -b over 2a. So in this case, +8 divided by 4 is 2. And then I have to plug 2 back in. So 2 times 4 minus 16 plus 6. So this would be -8 plus 6 is at -2. So my vertex is at 2, -2. I know that one of my intercepts is the y-intercept at 0, 6 because the c value is 6. 1, 2, 3, 4, 5, 6. So reflect that over this line of symmetry. This is a stretch of 2. So actually, when I go over 1 and up 2, I hit the x-axis. So, and then this would be over 2 up 8. So there's my parabola, and my other intercepts are at 1, 0, 1, 2, and 3, 0. This is in vertex form, so I can just read that the vertex has gone right 3 and up 5. So right 3 up 1, 2, 3, 4, 5. Then I look at my a value. My a value is positive 1, so this is just the parent function going up over 1, up 1, over 2, up 4, and then over 3, up 9. Doesn't fit on my graph. I don't have any x-intercepts, but I do have a y-intercept somewhere up here. So when I plug in 0 into this function, I get negative 3 squared is 9, plus 5 would be at 14. So I can find the intercept by plugging in 0 for x. Let's see, number 7 you can think of either as standard form or vertex form. I just think of it as vertex form. I'm not going right or left, but I'm going up 4. So my vertex is at 0, 4. I've been flipped upside down and stretched times 3. 1, 2, 3. And then usually I go over 2, down 4. 3 times 4 is 12. So I'm going to go over 2 and down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 for that other point. All right, so let's see. I don't exactly know where those intercepts are. I'm just going to write the x-intercepts are not integers. So I won't have you find those on the test, but my y-intercept was at 0, 4, so I could record the y-intercept. All right, and this is an intercept form, so I know that negative 1 and positive 3, 1, 2, 3 are my x-intercepts. So halfway in between would be at 1. So my vertex is at 1. I plug the 1 in to see the y value. So 1 plus 1 is 2, and 1 minus 3 is negative 2. So my y value is at negative 4. 1, 2, 3, 4, over 1, up 1, over 2, up 4. It hits the x-axis. I knew that it was just the parent function because the a value was 1. So my vertex was at 1, negative 4, and my x-intercepts were at negative 1, 0, positive 3, 0, and my y-intercept was at 1, 2, 3, 0, negative 3. So I could find all the points where I hit my axis. Determine if it is a polynomial or not. So this is, because these are all real numbers and these are all whole exponents, this is not. It has an imaginary coefficient, meaning an I, and this is not because it has a fractional exponent. It also cannot have any negative exponents. All right, number 12, write in standard form, state the degree, leading coefficient, maximum number of turning points, and max zeros. So let's see, this is almost in standard form. Negative 2x to the 5th plus 5x cubed plus 2x squared plus x minus 3. The degree is 5 because of x to the 5th. The leading coefficient is negative 2. The max turning points is 4 because that's 1 less than the degree. The max zeros is 5 because that is equal to the degree. Let's see, y equals negative x to the 5th plus 3x cubed plus 4x squared. State the degree. The degree, again, is 5. The leading coefficient this time is negative 1 right there. The max turning points would be only 4, and the max zeros would be 5 again. All right, I'm going to look at them in standard form. So this is my key player here. The right end is going to go down because of the negative 8. This is an even degree, so they will both go down together. Here's my key player. It's in standard form. The right end is going to go up because of the positive 2, but the odd degree is going to make the left end go opposite. And then here's the key player. It's kind of hidden. This is not in standard form. The right end will go down because it has a -1 in front of that x to the 6th, and the left end will go the same direction because it was an even degree. So I should have written this in standard form so that you wouldn't have been kind of tricked by that. All right, lots of factoring practice here. This is the difference of squares method. So I take the square root, 10x minus 9, 10x plus 9. So x will either be 9/10, add 9 to the other side, divide by 10, or -9/10. Looks like I've got a greatest common factor of 5. So I can pull out the 5 and then factor using difference of squares, x plus 5, x minus 5. So my two solutions are at -5 or +5. I'd have to use the box method or guess and check. So I'll show you the box method here. So we've got 3x squared 6, and then 3 times 6 is 18. They have to add up to the 11 in the middle. 9 times 2, 9x, 2x. And then you're going to fill in your box. So let's see, 3x times x, 3x times 3, x times 2, 3 times 2 is 6, it works out. So 3x plus 2, x plus 3 are my factors. So x is either equal to -2/3 or -3. I can pull out a 2x. X squared minus 16 is left. And then difference of squares, I would have x plus 4, x minus 4. So my three solutions are 0 or -4 or +4. This is called quadratic form, so we drop it down into a quadratic before we start factoring. I'm looking for the factors of -20 that add up to +1. So it's going to be 4 and 5, and I want the 4 to be negative. So x minus 4 times x plus 5. Then I need to square each of the x's to be able to get to x to the 4th. So x squared minus 4, x squared plus 5. I can use difference of squares, x plus 2, x minus 2. And then I've got this x squared plus 5 left. This is prime, so I only have these two solutions, -2 or +2. Number 22, I've got 4 terms listed out, so I can use grouping. And then what I would pull out of the first parenthesis is x squared, then I have x plus 2. What I would pull out of the second parenthesis is 3, and then I would have x plus 2. So x plus 2 factors out, and then x squared plus 3 is what I have left as those coefficients. This is prime, so my only solution is when x is -2. Number 23, that's the sum of squares, so that's prime. And it actually has no solution because it's a quadratic that's been raised up 100. So x has no solution. It's not factorable and it has no solution. This is the cubic formula, so I would give you a cubed plus b cubed equals a plus b, a squared minus ab plus b squared right on your test. So you're taking the cube root of these terms. So we would have 2x plus 3 because I'm taking the cube root of each of those terms to get my a and b term. Then I'm basically squaring these two terms. 2x times 2x is 4x squared. 3 times 3 is 9. To get that middle term, I multiply them together, and that is 6x. Change this to a minus sign, change this to a plus sign, and that is the fully factored answer. I would not have you solve this using the quadratic formula, but I do know that one of my x-intercepts is at -3/2. Okay, let's see. Describe the end behavior of the graph. The right and the left end are going to go up because there was a positive leading coefficient and the degree was even. It says find all the zeros if 5 is a 0. You could look at a graphing calculator to find the zeros. So let's plug this one into the graphing calculator. X raised to the 4th minus 7x, x raised to the 4th minus 7x cubed plus 11x squared minus 7x plus 10. So we know that one of them is at 5, and the other one looks like it's at positive 2. If I want to verify that that's exactly at 2, I can go into my table at 2 and just check, yep, 2 comma 0 is in my table. So 5 comma 0 and 2 comma 0 are my x-intercepts. Find the y-intercept. That just means plug in 0 for all the x's and you would get 10. Then graph the zeros, y-intercept, and end behavior. So I already looked at what this looks like, but here's 2, here's 5. We already said it goes up on both sides. This is at 10, and then it's doing something in between. Let's see. Be able to identify this stuff and find average rate of change. This is that open box problem. So I'm not going to be asking you the open box problem on your test. So you can go ahead and skip that one. Make sure you know how to do your area application on number 110 in your packet. And let's finish with this rate of change problem. So find average rate of change between x equals 6 and x equals 9. So first we need to generate the coordinates when x does equal 6. You can plug it in by hand. I like plugging it into my y equals menu. X squared minus 8x plus 16. I'm going to go to my table setup, start at 6. So 6 comma 4 and 9 comma 25 are my two coordinates. So now I do y2 minus y1 over x2 minus x1. So 21 divided by 3 is 7. For instantaneous rate of change, you're going to go to 5.99 and 6.01. I'm going to go to my table, setup, start at 6 and count by 0.01 on either side. So my two values are 3.9601 and 4.0401. So 4.0401 minus 3.9601 all over 0.02 on the bottom. 4.0401 minus 3.9601 divided by 0.02 gives me an instantaneous rate of change of 4.